Welcome to another lecture of Gauss elimination method. Here also you see there are three equations. So there is a system of linear equations with three equations having three unknown variables like x, y and z. So these three are the equations. 2x minus 5y plus 6z is equal to 6. X minus 3y plus 4z is equal to 3. Minus 3x plus 3y plus 4z is equal to 6. So now let us, as you have seen in the previous lecture, we have to find out the augmented matrix. So what is the augmented matrix here? From the first row, for x, the coefficient is 2. For y, the coefficient is minus 5. For z, the coefficient is 6. And on the right hand side, we will write 6. Similarly, from the second equation, the coefficient of x is 1. The coefficient of y is minus 3. The coefficient of z is 4. And on the right hand side, we write 3. On the third, from the third equation, we write the coefficient of x is minus 3, the coefficient of y is 3, and the coefficient of x is 4. And what we write on the right hand side, that is 6. So this is our augmented matrix. So finally, as you have learned from the previous lecture, the ultimate goal of Gauss elimination method is to find the row echelon form. And how you will find the row echelon form? You will find the row echelon form by applying the elementary row operations. So what is the row echelon form? That is kind of upper triangular matrix where the diagonal elements will be 1, below the elements will be 0, and the above elements will be anything. That is any non-zero value or zero value. That is immaterial. But this should be our focus area. That is, we have to maintain, we have to make this. It can be anything, and on the right hand side, that also can be anything. Okay, so that is our row echelon form. So, just let me delete this. What we can find, what we have already known, there are three row operations. First row operation is called the row interchange. That is, Ri can be interchanged with Rj where I not equal to j. Second, any row can be multiplied with a non-zero value. That means Ri can be multiplied with Rj. Ri can be multiplied with any non-zero value, that is k not equal to 0. Third operation, any row that is suppose Rj can be multiplied with any other row which is a multiple of any factor, that is Rj is equal to Rj plus Kri. So these are the three elementary row operations that we have to apply on the augmented matrix to finally obtain the row echelon form. Okay. Now let us see the augmented matrix first. You see, in the first position there is 2. In the second position, let us look at the first column. In the first column, so we will go column by column. So first the first column, next the second column, next the third column. So at the first column, the first value is 2, the second value is minus 1, the third value is minus 3. But as per the row echelon form, all the diagonal values should be 1. So here the middle value is, that means R1, R2, R3, R1, R2, R3, R1, R2, R3. So in place of R2 at column 1, the value is 1. So what we can do, we can interchange these two rows. Nothing will change. That means no meaning will be changed. So just we interchange row 2 with row 1. That is our first row operation. Okay. So what we will find? 1 minus 3. So now row 2 will be placed at row 1. 1 minus 3, 4. And 1 minus 3, 4. On the right hand side it is 3. 2 minus 5, 6. And it is 6. Minus 3. The third row remain unchanged. Minus 3, minus 3, 4. And it is 6. Okay. So that is our new matrix after doing the row operation, that is interchanging two rows R2 and R1. So that is our first augmented matrix that we have obtained after the row interchange operation. Okay. Now we will do another operations, that is another operations we will learn eventually, so that the other two values on row 1, that is first value will be 1, second value should be 0 instead of 2, third value will also be 0 instead of minus 3. After that we will move to column 2. So let us first make this to 0, then the next minus 3 to 0. Okay. So let us do that. Okay, so we have written the newly obtained matrix freshly. So at the very first position in the first column, we have obtained the 1. Now at this position, we have to make 0. At this position, we have to make 0. So just let me write R1, R2, R3. Okay. Now how to do this to 0? That is a very strategic way. What we do? R2 is equal to R2 plus, it is 2. So if I multiply row 1 with minus 2, that is 2. So if I multiply with minus 2 with row 1 is 1. So 2 plus minus 2 into 1, 2 plus minus 2 into 1, that will be 2 minus 2, so it will be 0. So at this place it will be 0. So similarly for this position it will be minus 5. So this is the operation. Okay. This is the operation. Just what we are doing, we are just doing this operation. So we find the matrix like this. 1, the first row remains as it is. That is 1 minus 3, 4, it is 3. Then 2 plus minus 2 into R1, that means 1. That means it is 0. Then it is minus 5 plus minus 2 into minus 3. So it is minus 3 in the first row. So minus 2 into row 1, that means minus 3. So minus 5 plus of 6. Minus 5 plus 6. So it is 1. The third value will be, this one is 6. So 6 plus minus 2 into R1, that means 4. So it is 6 plus minus 8, so it is minus 2. So 0, 1, minus 2. Okay. Let me just write down properly. 0, 1, minus 2 at the second row on the right hand side. Let me just write it down. So it will be 0, 1, minus 2, and on the right hand side what will happen? It is 6 previously, then 6 into minus 2 into 3, so it will be 0. So on the right hand side the value will become 0. I hope you have understood how this row operation is changing the row values. So we have obtained 0 here. Now let us move to the third row, that is third row first column, which is minus 3. So that minus 3 also should be made 0. So what will be our row operation? Similar kind of thing. R3 is equal to R3 plus, this is minus 3. So what will happen? We will just write the opposite value, opposite sign. So it is 3 into R1. Okay. Minus 3 plus 3, that will become 0. So it is minus 3 plus 3 into R1 means 1. So it is 0. The second value, 3 plus 3 into R1. 3 into R1 means minus 3. So 3 plus minus 9. So it is minus 6. The third one will be 4 plus 3 into R1. That means 4. So it will be 16. So 0 minus 6, 16. Let me just write down in a fresh way. 0 minus 6, 16. So it will be 0 minus 6, 16. And it will become the right hand side 6 plus 3 into R1. 3 into R1 means 3. 6 plus 9. That means 15. So let me just write down freshly. That is 15. Okay. So now this is our row 1, this is our row 2, this is our row 3, and you see our column 1 is 1 0 0. So we have obtained our desired column. That is 1 will be at the top, the first value will be 1, the remaining values lower below the value 1, it will be 0. So all the values are 0 now. Next we will move to the second column. So on this matrix, what we have just found on this matrix, we will do the other operation. So let me just write it down freshly. Okay. Okay. So what we have just found, we have found this matrix 1 minus 3 4. On the right hand side it is 3. 0 1 minus 2 on the right hand side it is 0. 0 minus 6 16 on the right hand side it is 15. Now we move to the second column. So what is our desired form? As per the form of the row echelon form, the diagonal element, that means 1 here, that should be 1. So it is already 1 here. Okay, so we have to do nothing. The next value, that is below this value, it is minus 6, but it should be 0. So we have to do the same thing as we have done in the case of column 1. So we have just written R1, R2, R3. Now what we have to do? So this minus 6 should become 0. Now the row operation will look like this. R3 is equal to R3 is equal to R3 plus, it is minus 6. So if I just multiply 6 with R2, it will be same, it will be 0. So what will be the matrix? The first row remains unchanged, 1 minus 3 4, that is R1. Next 0 1 minus 2, it is 0. Sorry, it is 3. And it is 0. It is minus 6 plus 6 into R2. R2 means 1. So it is 6 minus 6 plus 6. That means it is 0. Then it is the third one, 16 plus 6 into minus 2. That means minus 2 is at row 2. 16 minus 12, that means 4. Okay. So it is 0 0 4. Let me just write down freshly. The value will become 0 0 4. Okay. And it will be 15 plus 6 into R2, that means 0, so it will be 15. So let me just write it down freshly. So it is 15. So that is the augmented matrix after we do this operation on the. So just I have written it down freshly. So we have done these row operations. R3 is equal to R3 plus 6 into R2, and we have obtained this matrix. So you see, we are completed with the second column. That is, we have obtained the diagonal element 1 that was previously 1 also. It may not be 1, but in that case, you have to make it 1. And below 1, the value is 0. So we are completed with the second column. Now we jump to the third column. So what we have to do now? These 4. Here you see that. So what should be the third column value? This diagonal element, which is written as 4, that should be 1. So how to make this diagonal element 1? This is the simple row operation, that is the multiplication operation. So this is R1, this is R2, this is R3. So R3 is equal to R3 into 1 by 4. That means we have to divide by 4. That means R3 by 4. But this operation is not allowed. So what we are doing? R3 is equal to, we are just multiplying with 1 by 3. R3 into 1 by 4. We have to do this row operation. And if we do this, what will happen? All the other rows remain unchanged. 1 minus 3, 4. It is 0, 1 minus 2, it is 0. And it is 0, 0, 1. It is 15 by 4. 15 by, sorry, it is 15 by 4. Okay. So this one is at the appropriate place, this one is at the appropriate place, this one is at the appropriate place. All the elements below the diagonal elements are 0. So this matrix is in the row echelon form. So we have obtained our desired matrix. Now we have to do the back substitution. That is the last step of the Gauss elimination method. We have to do the back substitution. So let me just write down this matrix freshly, the final matrix freshly. That is the matrix that is in the row echelon form. So the matrix looks like this. That is 1 minus 3, 4, 3, 0, 1, minus 2, it is 0, and 0, 0, 1, it is 15 by 4. Okay. Now the last step is called the back substitution. Back substitution. Okay. So this is 1. Here what will happen? We will directly write. We will start from here. That is 1. So we just write Z is equal to 15 by 4. So Z is equal to 15 by 4. The next one, y, 1 into y plus minus 2 into z is equal to 0. So y plus minus 2 into 15 by 4 minus 2 into 15 by 4 is equal to 0. So it will be 15 by 2 minus 15 by 2. So y is equal to 15 by 2. And from the first row, it is 1 into x plus minus 3 into y plus 4 into z is equal to 3. We already know the values of y and z. So x plus minus 3 into y, that means 15 by 2 plus 4 into z, that means 4 into 15 by 4, that means 3. So what will happen? Just finally, if we write, just I remove this portion. Just let me remove this portion. So what will happen? X plus from this. X plus minus 3 into 15. That means minus 45 by 2. X minus 45 by 2 plus 15 is equal to 3. So x is equal to 3 minus 15 plus 45 by 2. What will be the value? This is minus 12 plus 45 by 2. So it is, I'm writing here because of shortage of space. So it is 2 minus 24 plus 45. It is 121 minus 21 by 2. So finally, what the values we obtain? Z is equal to 15 by 4. Y is equal to, Z is equal to 15 by 4. Y is equal to 15 by 2. And Z is equal to minus, X is equal to minus 21 by 2. So that is our answer. Okay. So just let me write it down properly. Okay, so Z is what we just say. Just let me remove this. What is our final answer? The final answer is like this. X is equal to minus 21 by 2. Y is equal to 15 by 2. Z is equal to 15 by 4. So that is our answer of the system of linear equations. Okay. So that is the method for finding out the values of the unknown factors or unknown variables using the Gauss elimination method. Thank you so much.